All right, folks, let's go ahead and get started. Welcome to today's IMS Tools Community webcast, provisioning databases in modern ways with Radek. Before I hand you off to him to get us started, just a few things I need to go over. First, if you have questions along the way, and we always hope that you do, we want these sessions to be interactive, please use the questions box along the right-hand side of your screen, right under the GoToWebinar control panel. Ask them there. We'll get through as many as we can during our time together today. If for some reason we can't get to all the questions, sometimes they require a little bit of research, or occasionally we run out of time, I'll make sure that the team gets everything they need to follow up with you after the fact. Secondly, we are recording today's session, and that's why your lines are all muted. The replay will be available out in the IMS Tools community sometime either later today or tomorrow. So if you have anyone you want to share it with, or if you want to watch it again, that's where you'll be able to find it. And the last thing for me is that we always want to make sure these sessions are as valuable as possible. So with that in mind, a short survey is going to pop up at the end. We would love to get some feedback from you so we can make sure that we are delivering the content that you expect and need. That's it for me. So take it away, Radek.
Okay, thank you, Len. Good afternoon, European attendees, and good morning, US attendees. My name is Radek Mrvec, and I think that maybe you already know me. I will be talking about myself a little bit later, but today I prepared a session about provisioning your databases in, let's say, different way as you are doing so far. So I prepared this topic during when I started to play a little bit with Ansible on Z and with IMS. So, and today I would like to share my experience which I get and also some knowledge which I obtained. Okay, so this session will be about 50 minutes long, approximately. And there is quite a lot of things to cover, so let's start and don't wait. First, let's start with some legal stuff. So there is a disclaimer, which is saying actually what you are allowed and what you are not. And it is also saying that everything in this presentation is a subject of change. In context of this presentation, it's really true, because, for example, I didn't imagine 5 years ago that I will be able to use the tools which I am able to use now. And on other hand, I also don't know what will be in following 5 years. So in our world, everything is changing quite rapidly. So, and that's what I am mentioning it here. Now, a little bit about myself. As I mentioned, my name is Radek Mrvec. I am from Czech Republic, where I work as a software engineer for Broadcom. And a couple of weeks ago, I had 10 years anniversary. And that 10 years also means that it's my mainframe experience. Before mainframe, I was working in, let's say, distributed IT world. And then I decided to join CA Technologies as an associate software engineer. And for 9 years, I am working in IMS Tools team. And my daily duty is working on enhancement and also on bug fixes, which you are finding in our tools and so on. Okay, if you will have any questions on me, or you want to know more about me, if you still don't know me, so you can visit my LinkedIn account and you can contact me also in this way. Well, let's start with the presentation. What is it all about? So this presentation is surprisingly about provisioning. But first, I would like to spend a couple of minutes with a definition. What provisioning means? What is it? Is it useful? Do I need it? So can it help you somehow? We will see. After that, we will take a look how database provisioning works outside mainframe world. So it means that I would like to show you how you can provision, for example, SQL Server database. So, and you will see if is it complicated, is it easy, you will see by yourself. After this example, we will take a look what steps are needed if we want to provision IMS database. We will pick simple HDAM database, nothing complicated, because you know how you are learning stuff. So you are learning, you are start learning with Hello World, and this one will be again a Hello World. And after that, after we will define all required step for provisioning, we will try somehow automate this process but a little bit differently. We will try to use some modern tools. I think if you read already abstract, you know that these tools will be Ansible. Okay, we will try to use Ansible if it will be suitable for all steps which we defined in the previous part. So let's start with the definition. Provisioning is the process of configuring and deploying an information technology system resource either locally or in the cloud. This is based on the Wikipedia description, and I really like this definition because it is exactly correct. Provisioning. You can provision, for example, user. What it means? Actually, it means that you are creating user account from scratch. Then you are following some kind of process. And at the end of this process, you have usable user. You can do the same with application. Provisioning of application is the same thing. You first need to get install media, then you need to install application, configure application, start application, and use application. And again, this process is provisioning of application. Usually provisioning is also combined with cloning. What it means? It means that, for example, for that user, you have a user Bill. Bill already have created account and is usable, and that account is working on your system. Doesn't matter where the system is. And you want to create new user, which will be Jim. And the Jim will have the same properties as Bill has. So you only need to change the name. So, and again, it is provisioning. You will take the model, which will be Bill, and you will create it Jim user account, which will be modeled based on the Jim account. And still the process which you need to follow is provisioning. Now, I pick 3 case studies which will introduce you where you can use this kind of provisioning. Maybe if you take a look at these 3, you immediately will start to have much more of them. So, but let's talk a little bit about these 3 cases. First one, development. Okay, let's assume that you are a developer and you are working on some enhancement on fix for your database application. You have production database, which is still online. You don't want to take it down, of course. So, and you have actually 2 options. First one is that you can start working on your code changes against production database, but it's not clever, you know. So you don't want corrupt production database, which is live. So it's very risky. So better solution is that you will create own database, which will be same as the production one, which means it will contain almost the same data. It will have the same structure, but will be in isolated environment. And again, it is database provisioning. This case is for development. For testing, it's quite similar. Again, you want the test that fix which was created in the previous example, for example, and again, you don't want to test it against live production database because you don't want to bring it down, of course. So the better choice is create another instance of the same database and then test it against this newly created instance for testing. And for analytics, it's a little bit different because when you are doing analysis of your production data, actually, you don't care about the most recent data. So because data are changing, let's say every seconds or even every milliseconds, why not? So, and if you are doing some analysis of data, it is taking time. So in that case, you are more interested in some kind of snapshot of your data, which can be 1 day old, for example. So, and this is another use case for database provisioning. You will create another database which will be same as the production one, but will contain 1 day old data, and then you can run analysis as you like. So now I believe that after these studies and definition, you are already familiar what provisioning means. And I also think that you already knew it before I started this session. So because provisioning is everywhere, it's buzzword currently. So and everybody is talking about provisioning, but the truth is that not everybody knows what it really means. So when we are start talking about provisioning, there are plenty of challenges. So I pick these three because I think they are quite important. One, and they need to be somehow solved. First one is size of database. We will be, in the rest of this presentation, we will be talking about provisioning combined with the cloning. So we will be cloning our database with a provisioning process, okay? So, and in question of size of database, there is a problem because when you are creating new database, you need reserve some space on your devices. And for that, you need to know how that original database is large, how huge is it, how many data it contains. So that's one challenge which needs to be solved on, needs to be keep in mind. Another one is production data. I don't want to talk too much about this challenge. I only want to mention it here because it's very important. And the problem is that your production data contain sensitive information. And we don't want to work with sensitive information during our development or testing or whatever. So, and for that, we need to somehow solve this challenge. There are multiple options. You can use data cleaning. You can use data masking. You can use some business intelligence tools which will help you during this process. I am only mentioning it here because it's very important, and talking about how to clean or data mask or data, it's for another set of presentations. So it is really out of scope of this presentation. But again, it's another of challenges which you will meet during the provisioning. And the third one is timing of provisioning refresh. As I mentioned before, of course, if you are an analyst, so then you don't need really accurate data, which will be refreshed every second. So it's nonsense. So, but if you are tester or developer, so that refresh time will be different because you are working on some feature which is required refresh every hour or every minute. So, and again, it's another challenge which you need to solve before you will start with database provisioning. And how to solve them? There is more ways, but in my opinion, the very important one is automation. If you want to solve these challenges, for example, the time refresh or the database size, the automation is a key. So if you automate all the process of provisioning your database, that there will be minimal human interaction with that process. So you can be sure that at least you will omit every human disruptions, let's say. So automation is really very important in this process, and it is a key, and we will spend quite big part of this presentation only about automation. And frankly speaking, I think that we all are working and thinking about automation. If you are developers, you usually try to automate all your processes which you are doing, and that's the key, how to save time and also save your money, of course. And another one is communication. During the database provisioning, there is very important to have all involved people knowledgeable about that process, because everybody can step in and everybody needs to know what database provisioning means and how it is working and what everything is required. That means that communication is also very important in this, and it helping to solve these challenges. Let's start with SQL Server provisioning. Why I pick SQL Server? I mean Microsoft SQL Server. There is only one reason, because I have some experience with this one. So, but I believe that, or I'm pretty sure that all these steps will also apply to other SQL databases like Oracle, MySQL, and others. So I split this provisioning process to 4 steps. First one is that for that SQL Server, we will try to clean sensitive data from the database. Then, since we are trying to combine it with cloning, we will backup our cleaned database. Then we will restore to test environment, and we will restore to development environment. After this point, you will have 3 instances of the same database. You have the original one, and then you have the one for testing and one for development. How to do that? In SQL Server, you can pick multiple options. I picked the PowerShell way because PowerShell is really power. It's a Microsoft product. And in combination with Microsoft SQL Server, it is offering really great functions and functionality, which is helping in your task. So first step is that we will try to clean data. It's quite naive cleaning here, but here we are trying just delete all the email addresses because we are counting email addresses as a sensitive data, and we are replacing them with some dummy email address. So, and that's doing this step. It's taking the database, the table users, and then it's trying to update all the emails with that email address. That's the first step for the cleaning. The next step is taking backup. In PowerShell, you can take backup really easily. So you will just specify your database, which is so dirty, and then you will specify backup file, which in this case is so clean.back, and that's it. After this command, you have the backup file which backupped your database. For reverse, which is restore, it's very similar. Again, here we are trying to create the new database, which is named our database here, and we are using the backup file so clean, which is in the last line here, and that's it. After this point, we have the new database, which is called our database, and it is the same database as it was in the first step, which was so dirty, I guess. So, and that's it. So really easy. And if we are talking about automation, it is scripting. It is shell script, which is contained three steps. And of course, you can replace all these hard-coded string with some variables, which can be based on user input, and that's it. Other way is through UI interface. Microsoft SQL Server is offering Management Studio, which looks like these 2 screens. And you can do database provisioning also from that studio. And again, it's question of couple of clicks. First, on the left side, you can see that we are trying to do some backup, which is just 2 pop-up windows. And after that, when we are trying to restore, it is again right-click to databases node and then restore database, and then we will point to the backup file and a new database will be created also with data. Management Studio is quite clever. You can also pick if you want to do the backup with the data or without the data, and there is a lot of other functions. The purpose of this one is that first, before we start talking about IMS and Mainframe, I wanted to show you how database provisioning easy is outside the Mainframe in SQL databases. And now, let's jump to IMS topics. As I mentioned before, I picked a very simple database, which will be, in our case, some HDAM. This database will be registered in DBRC. And first, let's take a look what provisioning of that database means in IMS context. So first, we need to backup production database. It is same step as we did for SQL Server, so there is no surprise. The next step is different because now we need to create and register new database definitions, which means that we need to have some DBDs and PSBs and register them to IMS system. After that, if we are using DBRC and we want to use DBRC also for our new created database, we need to register that new database in DBRC. The next step is allocating datasets for new database. We need to allocate some space where our data will be kept. So for that, we need the datasets here. And after that, we are prepared to restore our backup, which was created in the first step. And after restore, we are prepared to start new database. And that's it. These 6 steps is the simplest example of provisioning of IMS HDAM databases. Of course, in real world, that scenario will be probably much more complicated. Of course, for other database type, for HDBs, it will be complicated. There will be multiple steps because you need to create more stuff. But as I mentioned in the beginning, we are start to learn how to do that, and we are starting to learn it on Hello World, and this is the Hello World. You see 6 steps here, maybe 5 will be enough if you omit that DBRC step. Now let's take a look a little bit deeper at every and each step. First one, backup production database. So you can say that you can do just the unload and then you have a backup file. It is partially correct, yeah, but if your production is online and you really don't want to bring it down because of some provisioning or unloading. So the other idea which I picked as my favorite is that I will use unload from image copies. For that, you can, for example, use our database organizer, which we are offering. And I believe there are also other tools for this task. And on other hand, there is also thing that I believe that in your shop, you have some strategy for creating image copies and you are creating them, let's say, regularly. So, and in that case, you are maybe interested in just some point in time, yesterday or 5 days back. So you can pick that already created image copy and do the unload from this image copy. Why not? So, and in that case, you don't need to touch your production database. You are just touching some image copies which are stored somewhere and use them. That's how you can pick up your production database. Next step. Create and register new database definitions. Here, in this step, we need to distinguish between 2 environments. Because I know that not everybody is currently using managed ACB, and there is still plenty of IMS users which are using ACBLIB environment. And that's why I am using these 2 approaches here. For managed ACB's environment, it's easier, let's say, because you will need just select information from your catalog, then extract this information, and just you execute the create database DDL, and that's it. In ACBLIB environment, it's a little bit more complicated. So because first you will need a DBD source, because maybe you plan to change database name, at least if you will create the database instance in same IMS systems, then you will need to change the database name. And for that, you will need to get DBD source, modify it, and then run through DBDGen, PSBGen, and ACBGen process. Then you will need to issue the create DB type 2 commands for creating the IMS resources. And then you will need to use command init OLC for switching the active ACBs in your IMS systems. So it is a little bit more complicated, but still it is doable. So still it is doable, and you can use that database provisioning in both environments. You don't need managed ACBs if you want to do the database provisioning this way, as we are showing here today. Register new database in DBRC. If you are using DBRC on your original database as we are, then you will need to get some information from DBRC, and you will use this information in the DBRC for the new database. So it means that first you will need to issue list DB and DBDS for getting the dataset list. And after that, you will need to do the init DB and init DBDS for the new database. Allocating datasets for new database. Again, there are two options or two possibilities. You are using VSUM or OSUM, and you will need to allocate datasets for your new database. And that's a quite tricky part because of the database space, as we mentioned in the provisioning challenges. So for that, you need to know how the original database is big. And what is great tool for it is using the itcomes utility and command define cluster or alloc, which is also offering clause model or like, and in the model or like, you can use your model, which means in this case, the original database datasets. In that case, almost all the parameters from that original database will be also copied to newly allocated datasets. I'm saying almost because not all parameters are copied. For example, SMS parameters are not copied through this process. And if you need the SMS parameters also to involve in the new datasets, in that case, you will need involve other techniques like example list cut or other techniques which are available, but still everything is doable. And in that case, quite easily, if you know what was the original database datasets, you can easily allocate the datasets for your new database with the same parameters. After that, we are ready to reload new database from our download file, which we created in first step. And after unloading, we can finally start new database with type 1 or type 2 command. And in this point, we have two databases with the same structure and with this almost same data and with the different names, and we are prepared to work on that second database in our isolated environment. And now the most important part is coming, and it is automation. Everything is nice. Now you know what's involved in the provisioning of IMS database, but you see that it's quite a lot of work, right? So let's try to automate it. So let's try to create some kind of script which will require minimum information. Let's say it will require only DBD name and IMS ID and Plex name, and that's it. So no more information is required, and the rest do automatically. We can pick from these three automation frameworks. You know JCL, and you are using JCL for years, and you are using automation through JCL for years, because every JCL which containing more than one steps is probably automation. That's one thing. So, but this session isn't about JCL. It is about using something different, because I want to show you that there is no only JCL. There are also other alternatives which are doing the same work. I'm not saying that JCL is bad, but time is changing. And for example, if we want to keep mainframe live, let's say, so we need also to try to adopt that new technologies, and that's what IBM is also doing. That's what Broadcom is doing. So we are trying really to bring these new technologies which are used also outside the mainframe in cloud systems and so on. We are trying to use them also on mainframe because mainframe was historically always different, and now we are trying to create mainframe similar. So to act the same. One of reason also can be that we want to attract young people to work with mainframe. And believe me or not, it will be much easier for them to use that new stuff in compare with the JCL, which they never heard about. So another option is Zowie. Zowie is another option because Zowie command line interface is also offering plenty of functions, for example, for submitting jobs and so on. And you can easily write any shell script and execute from the shell script some Zowie commands. It's one way, but unfortunately, Zowie is not offering so many functions like Ansible is offering. So, and that's why I picked Ansible, because you will see later that Ansible already contains plenty of modules which are prepared for our use and our tasks. So let's start to automation the process of provisioning. So we will pick the Ansible and we will pick the Python because some side scripting will be needed in this process. Why Python? So because Ansible is written in Python, so and if you are able to run Ansible, you are also able to run Python scripts. So it's easy. So that's one of reason, but there are more important reasons which I will cover on the next slide. So this session isn't about Ansible, because if I will be talking only about Ansible, I will need a whole session only for Ansible topic. So, but for those don't know Ansible, so let's do some quick brief introduction to Ansible. What is it? Ansible is really very simple architecture. It is not any server, it is framework. So it means it is a set of libraries which can reside on your desktop machine or laptop, or it can reside on any server machine, doesn't matter. And Ansible is fully written in Python. So in a simple scenario, Ansible is consuming two files. One is inventory, which is describing your targets. In our case, it will be our mainframes like URL and so on. And playbook is some kind of script which is describing what you want to do on your target. Which means, for example, playbook is saying that I want to copy this file from this location to this location. I want to delete this file and so on. And that's what's described in playbook. Ansible is taking these two files, creating Python payload, and then through SSH is transferring this payload to our server, which will be mainframe in our case, execute it here, waiting for results, and send results back to Ansible master. And that's it. It's really very simple architecture. Of course, there are other things like Ansible Tower, which is web server, but I don't want to talk about it here. But let's take Ansible as a simple scenario which is working, and this is this one. Another good thing is that you can see in this slide that it's great for scalability, because you can decide if you want to execute it on one target or two or three or how many you wish. So you can also group all these targets in groups and then issue your playbook against groups. So everything is possible, and it's very easy. That playbook is in YAML syntax, which is quite popular syntax, and it is used for configuration. For example, Docker is also using the YAML syntax for configuration. So and that's about Ansible. If you are interested more about Ansible, there is tons of materials on the internet, a lot of courses, a lot of tutorials, and many others. It's really awesome technology, which is provided by Red Hat. It's here for, I believe it will be 10 years, maybe more, but it was adapted to mainframes, I think 3 years ago, and it is still growing. And currently, a lot of IT industry is already using Ansible, not on mainframe, but in other part of IT. Well, so what we need to do first? First, we will need to prepare our environment for that provisioning, for that Ansible provisioning. What does it mean, prepare environment? Actually, it means just collection of variables. So there are plenty of types of variables: security variables, mainframe variables, local variables, IMS variables, and others. There are many of them. So, and you need to collect them and give them to Ansible, because Ansible will need them. Ansible needs to know your user ID or your SSH keys. It needs to know URL. It needs to know your IMS ID, IMS plex name, and others. So, and that's why we need to collect these variables and prepare them for the Ansible. It's about types, but there is a one challenge here, because we have two types of variables. We have static variables, which are known in front. Before you start your provisioning, you will know usually which IMS ID will be used. You will know which IMS plex will be used. And that's the static variables, because we know them before we start our process. And there are dynamic variables which we don't know. And that's the tricky part. Because, for example, you want to provision some database. And as I was mentioning before, probably you will need to know which data sets are assigned to this database. Of course, you can take this information in front, but that's what we don't want. We want to do that somehow automatically. And for that, Ansible is offering one solution. There is an example of playbook. Maybe if you see the playbook for the first time, it can be confusing, but the truth is that for this session, I am somehow assuming that you are somehow a little bit familiar with Ansible. But in this simple playbook, we have some simple script. That script is just writing test word to standard output. And then in tasks, we are executing this script, taking the output, which will be the word test, and then we are using this output later in other tasks. And that's the way how you can handle dynamic variables. So, for example, let's assume that your first task will do the list DBDS for database. The output will be the list of data sets. And the next task will do the allocate with the model of the data sets which you obtain in previous tasks. And that's how you can handle this. And there are many of use cases for this one, but here you can see that it's quite easy, and the magic is in simple thing, and it is that you can register output of previously executed task for later use, and that's it. There is another challenge, and it is calling external tools. Currently, IBM is offering, I think, 7 or 8 collection for Ansible. Collection means set of Ansible modules. And one collection is, for example, IMS collection. And in that IMS collection, you can find DBDGen module, PSBGen, ACBGen, IMS commands, DBRC commands, and so on. But for example, if you want to do unload, there is no module for unload. So you will need to do it differently. But you know that if you will do that, for example, from JCL, you can just call, for example, our database organizer, which will do the unload. Why not? Now we need to have some similar way for Ansible. Of course, Ansible is offering ZOS submit JCL module, which is executing JCL. That JCL can be stored on a local, it can be stored on the mainframe, and that module is just executing the JCL and returning you the output. That's one way. But for that, you will need that JCL, or at least you will need the skeleton of JCL and then dynamically pull all the variables into the JCL and then execute it. That's one way. Other way is, which is really almighty module, which is ZOS MVS raw. This module is directly calling any MVS program, and you will just need to allocate all the required data sets. In this case, is STEP-lib, DBD-lib, database dataset in this example, database unload data sets, and so on. And then you specify here, in this case, the last line on the right side function equal unload dbd equal d200 DBRC equal no. And if you execute this task, it will be same as you will executing JCL for database organizer unload function. The good thing here is that the right side of this pair here, for example, content, and the right side of the content can be substituted with any Ansible variable. So for example, the input variable for our playbook will be database name. And here, as we are writing dbd equal d200, instead of this d200, we will just use that variable which was obtained from user in execution of the playbook. And that's it. And you can replace any of these variables here. So not only this one, but every right side of this YAML can be replaced with a variable, which is really awesome. And if you prepare in previous task or step some input, you can generate these inputs and easily later use them in these playbooks. So that's for calling external tools, about how to call them. This example is about database organizer, but for example, you can use also this one for it comes. If you want to allocate your data sets through the it comes, yeah, sure, it is the same way. You will use, instead of program name, you will use it comes and allocate appropriate data sets and create the control statements, and that's it. Next slide is about create database definition for ACBLIB environment. As I mentioned, it's a little bit complicated because you will need the database source for some, at least, name modification. And for that, you will need to execute some decompile utility. We are offering ICB product, which is decompiling DBDs. I don't know if there are some alternatives here, but if you don't have your source DBDs and PSBs, you can call with the mechanism which was shown in previous slide and call that utility which will decompile your DBD and PSB, then modify them in some simple Python script, and then you will run the DBD gen, PSB gen, and ACB gen tasks, and that's it. After that ACB gen, you will have newly created ACB stored in your ACBLIB, and that's it. In managed ACB environment, it's a little bit easier, because for the first, to get information about database, you can use DDL generation batch utility, which is IBM utility. And it's, again, it is external utility which can be called. And if you give the database name to this utility, it will create database statement for DDL, and then you can use it in your next task. So here in this example, we are calling that DDL generation batch utility, which will create DDL statement. Then there is an example of Python how you can easily replace DBD name in any strings, which is here. So we will replace my DBD name with a new DBD. And then we will use another IBM utility, which is SQL batch utility. And this utility is for executing DDL scripts against online IMS system. And after that, if we will provide this DDL, that new database will be created in our IMS system. And also currently that DDL is supporting auto create, which means that also resources are created for create DB. You don't need the type 2 command, and these kind of resources are created automatically. Here is the how you are creating the resources in IMS systems through the Ansible IMS module. This Ansible IMS module is IMS command, and with the help of this module, you can execute any command against the IMS systems. You only need to specify the Plex name, IMS Plex name, and IMS ID. And that's the information which you probably will have in the beginning of the process. So you can use these variables which you get from the user who is executing this playbook. And it is for the scenario with ACBLIB, because if you will be using the DDL, you don't need to do this step, because this step is done automatically. Next one is registering database in DBRC. And here again, IMS Ansible collection is already containing module IMS DBRC. And with the help of this module, you are able to execute any DBRC command against your IMS systems. You just need to specify your recons, or you can also specify the dynamic library here. And after that, after these two commands, you will get some classic list DB and list DBDS output. With the help of Python, you can easily parse it, retrieve all the required information which you will need later, and then you can generate that init DB and init DBDS. Again, these commands on the right side are hard-coded here, but in the real scenario, you will use some variables, and these variables will be prepared in that Python script which is running before this task and is working with the previously generated output from the listDB and listDBDS. Allocating new database datasets. So first option is that you can use module from the US core connection, which is the US dataset module. But the problem with this module is it is allocating datasets. That's correct. But for this one, you will need to know all the parameters like space type, space primary, secondary, record length, block size, and so on. And that's what we don't know. So because we don't know, we can get this information, but it will be quite complicated way. And if you compare, as we showed before, that you can use itcomes, and with itcomes is really easy. So through the mechanism of external call, you can call the itcomes with alloc ds name like, and to like, you will provide the database dataset which you get from DBRC. Of course, if you are using DBRC. If you are not using DBRC, that process will be slightly different. But now we are talking about process which is expecting that you are using DBRC. And final touches. Now we are ready to reload our database. And for that, again, we can use, for example, database organizer, which will reload and use the previously created unload file and reload it to our newly created database. And after that, we need just to start our database, which we can do with the help of IMS command module from Ansible collection. And again, we will use the IMS Plex name and IMS route. And that's it. In this point, we have a script, which is playbook. In our case, we have, I don't know, three side Python scripts, but really simple ones, nothing complicated, couple of lines of code. And we need only 3 inputs. We need database name, we need the IMS ID and IMS Plex name. And with these 3 information, we are able to automatically create new database which will contain the same data and it will be clone of the original database. One more thing here is that, for example, Ansible is also supporting conditions, which means that you can execute tasks based on any conditions. For example, you can set condition DBRC yes or no, and if DBRC will be set to no, then you can skip the DBRC task and don't register the database in DBRC. So it's easily, and it's not complicated. It's based on variables, Ansible variables, which you can get from any output. And now we are approaching to the end of this session. So now I want to share my personal opinion why Ansible. So I want to give you some motivation why to start, at least to think about Ansible, or at least to try Ansible. And one thing is that there already exists tons of modules are available. So as I mentioned, Ansible is here for 10 years, I think at least. So, and there is really thousands of modules and hundreds of collections which are collected in Ansible Galaxy, and you can find whatever here. So really there is a lot of things. For you, more interesting is second thing, which is growing the US module collection, because when I started to play with Ansible and IMS, so there was I think five collections. It was your score, IMS, Kicks, and one more. And now, if I'm correct, there is 7 or 8 of them already. So really, IBM is really investing a lot of effort to the Ansible, because it's quite aligned with their strategy as to moving to hybrid cloud and so on. And again, they are trying, and we are trying to using modern tools on mainframe, which wasn't common in past, but now I think it's a good time to do that and invest into it. Easy to install and maintain. Again, Ansible is just a set of libraries, so there is no need. It's free. It's open, so there is no need any complicated. It's based only on Python, so and you can run it everywhere. You can run it on Linux machine or on any virtual machine, and anywhere you like. Great scalability. Again, as I mentioned in the slide with architecture overview, so you see that it's really easy to decide if you want to execute it against one node or against multiple nodes. So it's really very easy. And the last one is that's greatly accepted and used in IT automation currently. So, and now I am not speaking about mainframe. So it's really hugely used outside of the mainframe. And again, if you will get new hire from universities, you can be pretty sure that he will know what Ansible is, but he will not know what JCL is. So that Ansible is really great thing. And now one example from today, because today I was before one task, and I was before the decision if I will need to create new JCL for DBDGen, or if I will use that module. So I picked that module because it was much quicker for me than write that new JCL, because that module for JCL is for generating for DBDGen is really easy to use, and I can use that modern IDs for it. So, and that's why I picked this one. That's one real life example from today's, which I would like to mention. Okay, so we are approaching to the end. Yeah, so it's all from me. So I hope that at least it gave you something. If you have any questions, so maybe this topic will be quite new for you. Just let me know through email or through LAN or whatever, through community. So I will be happy to help you with your journey to Ansible, so I can point you some resources where to start and so on. So thank you very much.
Thank you very much, Radek. I don't see any questions, folks. We'll give you about 30 seconds to type anything if you want to ask any questions. I'll also remind you that we do have our post-event survey that's going to pop up here at the end. And if you're typing something long, please feel free to just put wait in the questions box so we don't close out before you have a chance. All right, I don't see anything, so we can go ahead and wrap up. Radek, thank you very much. And to everyone who joined us, we really appreciate you giving us some of your time today, and we will see you out in the communities. Have a great day.
Thank you.